Good day, friends, and you are again welcome to another WASI online experience. My name is Philip, and I'll be your instructor for today. But before we start our activity for the day, I'll need you to subscribe to our channel if you've not already done that. Remember, once new videos are created, you'll be sent an alert if you have subscribed to this channel. To be able to do this, you simply need to go below the video and tap the subscribe button. Alright, thank you very much for doing this for us. Let's look at our activity for the day. We'll be looking at another topic in core mathematics. We'll be looking at algebraic expressions. Today, we'll be looking at the part 1 of algebraic expressions. And under the part 1, we'll be looking at introduction to algebraic expressions. I believe we are ready for today's lesson. So I guess we can start now. At this point, I'll be introducing you to algebraic expressions. To enable us do this, let's look at the following terms. First, we'll be looking at the term numerical expressions. Then, we'll be looking at the term variable expressions. Let's write the mathematical expression 2 plus 4. This mathematical expression 2 plus 4 contains two main things. First, it contains numbers, the numbers 2 and 4. It also contains mathematical or arithmetic operations. And in this particular case, this expression contains addition or plus. Remember, there are other mathematical or arithmetic operations such as minus, multiplication, division, etc. I'll need us to note that mathematical expressions that contain numbers and arithmetic operations, numerical expressions. An example is the one we have on the screen, 2 plus 4. It is a numerical expression because it has numbers and a mathematical operation. Let's generate another example. We can have 3 divided by 1. It's also another example of a numerical expression. Another example, 15 divided by 3 is also another numerical expression because it contains only numbers and mathematical operations. So as simple as that. Let's look at the variable expression. Now, let's write the expression or the mathematical expression 2 plus y. Now, the y in this mathematical expression is called a variable. This variable is simply a letter that represents one or more numbers. So I'll need you to first note that. So now let's ask ourselves, what items can you find in this mathematical expression? So first, in this mathematical expression, we can find numbers. that is the number 2. We can also find an operation sign, the plus sign. Then we can find our y, the variable. At this point, let's note that any mathematical expression that contains numbers, operations or mathematical operations, and variables is called a variable expression. As simple as that. Let's also note that variable expressions are also referred to as algebraic expressions. So we've established that algebraic expressions are mathematical expressions that contain the following: numbers, variables, and mathematical or arithmetic operations such as addition, subtraction, multiplication, division, etc. Let's look at the examples of algebraic expressions. So we have our first example, example A, which is 2x plus 5 minus 7x minus 12. As you can see, this expression or this mathematical expression contains numbers, it contains the variable x, and it also contains operations such as addition and subtraction. Example B, we have the algebraic expression 3 into brackets m minus y bracket closed plus 2m minus 6. And here too we have numbers, we have the operation sign negative or minus, we also have positive or plus, and we also have another operation sign, the bracket. So this is a very good example of an algebraic expression. For example C, we have the algebraic expression x plus into bracket 7d minus 16 bracket closed divided by 3d. This is also a very good example of an algebraic expression because it has variables, it also has numbers, and it also has operation signs such as plus, minus, and division. It even has the bracket sign. The bracket sign is another operation sign in mathematics. Now, I'll need us to note this. We have 5x plus 7 equals to 10. I'll need us to note that this mathematical expression is also an algebraic expression because you have numbers in there. We also have the variable x, then we have the operation signs plus and the equals to sign. Now, but because of the equal to sign found in this expression, it is specifically referred to as an algebraic equation. So any algebraic expression that has an equal sign inside is called an algebraic equation. And I'll need you to note this. For now, We would focus on algebraic expressions that do not have equal signs in them. In the future, we'll be looking at algebraic equations and how we can handle these algebraic equations. Still under introduction, I would want us to look at the structure of an algebraic expression. So we have the algebraic expression 2x plus 5y minus 8x plus 3y minus 10. And I believe that we agree that this mathematical expression is an algebraic expression. The reason being that it contains numbers, it also contains variables x, y, then it contains operations. You can find addition there. You can also find subtraction in this expression. So it is an algebraic expression. We already know what variables are as far as algebraic expressions are concerned. You know that letters that are used to represent numbers in mathematical expressions are variables. And in this case, we have the letter x, we have the letter y, we have another letter x, then another letter y. These are the variables in this algebraic expression. Now, in front of the variables, you can find numbers. So in this algebraic expression, you can find numbers in front of variables. These numbers that appear directly in front of the variables are called the coefficients of the variables. So, for example, this number 2 is the coefficient of the variable x, which is behind it. Let's look for another coefficient. This 5 is the coefficient of the variable y behind it. Remember that when you are taking the coefficient, you always take it with the operation sign in front of it. We said the coefficient is 5 because there is a positive sign in front of it. So saying 5 is another way of saying positive 5. So because we didn't want to say positive 5, we said 5, knowing that 5 is the same as positive 5. So let's note this carefully. And this negative 8 is the coefficient of the variable x that appears behind it. Remember, the coefficient is not just the number, it also includes the operation sign in front of it. In this case, we have a negative sign or the minus sign in front of the 8. So the coefficient is not just 8, but it is negative 8. Now, what do you think is the coefficient of this variable y? Well, that is the coefficient of this variable y. It is positive 3, or simply put 3. So we know what variables are. We also know what the coefficients of variables are. Now let's look at what constants are in algebraic expressions. Constants are numbers that stand alone in algebraic expressions. It is important for us to note that when we are choosing constants from algebraic expressions, we choose the numbers that stand alone together with the operation sign in front of them. The operation sign could be positive, it could be negative. So let's remember this. We will look at an example and you appreciate what constants are when we give that example. So this number -10 is the constant in the algebraic expression because the -10 stands alone. It doesn't have any variable by it. Remember, you are likely going to be tempted to think that the constant is 10, but the constant is not 10 because remember it has a negative number in front of it. So it's not just the number 10, but it also includes the operation sign negative which is in front of it. So therefore our constant in this expression is -10, not 10. Now let's look at another interesting thing about algebraic expressions. For this algebraic expression, 2x plus 5y minus 8x plus 3y minus 10, you would realize that you have pieces of mathematical expressions, either algebraic expressions or numerical expressions that have been joined together to form a larger expression. Let's quickly look at these pieces of expressions that join together to form this larger expression. The first piece of algebraic expression is 2x. Remember, this is actually positive 2x. The reason is 2x, the 2 without any sign in front of it simply is a positive number. So it's actually positive 2x. Now, positive 2x contains 1, an operation sign which is the positive or plus. It also contains a number which is the 2, and it also contains a variable which is the x. The second algebraic expression in this larger expression is positive 5y or plus 5y, and it is an algebraic expression because the positive or the plus is an operation sign, 5 is a number, and the y is a variable. The third piece of algebraic expression in this larger expression is minus 8x or negative 8x. And I believe you know why this little piece by itself can be described as an algebraic expression. It has an operation sign which is the negative sign or the minus sign. It also has a number, that's the number 8. Then finally it has a variable which is x. Let's look at the fourth piece of algebraic expression in this larger expression. This is plus 3y or positive 3y. This is an algebraic expression because it contains an operation sign, the plus sign. It has a number, that is number 3, and it has a variable y. Now let's look at the last piece of expression in this larger algebraic expression. It is minus 10 or negative 10. This mathematical expression is not an algebraic expression because it contains only an operation sign and a number. I believe you remember what this expression is. It is actually a numerical expression. Now, what I would want you to note here is this. All these pieces of mathematical expressions come together to form a larger expression called the algebraic expression. These pieces of expressions that join together to form the algebraic expression are what we call the terms of the algebraic expression. So what this means is that this algebraic expression 2x plus 5y minus 8x plus 3y minus 10 contains 5 terms. Its first term is 2x or positive 2x. Its second term is positive 5y or plus 5y. Its third term is minus 8x or negative 8x. Its fourth term is plus 3y or positive 3y. Then finally, its fifth term, the last term, which is a numerical expression, is minus 10 or negative 10. At this point, we know what the variables of an algebraic expression are. We also know what the coefficient of variables are. We know what constants are in algebraic expressions. We can also identify the terms of an algebraic expression. Let's pay attention to the following. So far, we know that it is very possible to have an algebraic expression with a lot of terms, like the one we looked at earlier. It is an algebraic expression with 5 terms. It is also very possible we can have an algebraic expression with just a single term or one term. For example, this algebraic expression, negative 15m, is in just a single term, one term. Now, algebraic expressions with one term are called monomial expressions. Remember, the prefix mono means one. So monomial expressions are algebraic expressions with just one term. For example, you can see on the board or on the screen, negative 15m. It is in just a single term. Also, we can have an algebraic expression in two terms. For example, 2x plus 9. This algebraic expression is in two terms. The first term is 2x or positive 2x, and the second term is positive 9 or 9. Algebraic expressions that occur in two terms are called binomial expressions. Remember, the prefix bi means two. So binomial expressions are algebraic expressions with two terms. For example, we have 2x plus 9. It is in two terms. Let's look at the final example. We have 7y minus 2m plus 13y plus 6. This algebraic expression has four terms. The first term is positive 7y. The second term is negative 2m. The third term is positive 13y. And the fourth term is positive 6. Now, algebraic expressions that have more than two terms are called polynomial expressions. Remember, the prefix poly means more. So, since the example C has more terms, it is called a polynomial expression. Alright, so we are still under introduction to algebraic expressions. Let's look at another interesting item. Like terms and unlike terms. In basic school, I believe you heard of these statements. We are just going to look at them again to just refresh our minds on what these items mean, because we need them when we get to operations on algebraic expressions. So we just need to look at them once again so we will be able to apply them in operations on algebraic expressions. So far, we know what the terms of an algebraic expression are. Two terms of an algebraic expression are said to be alike if they have the same variable and if the variables also have the same exponent. So two things: same variable which are of the same exponent. This statement is self-explanatory, but well, let's digest it with the following example. So we have the algebraic expression 2x plus 5y plus 2 minus 8x plus 3y minus 10. This 2x or positive 2x is the first term of this algebraic expression. Now let me select another term of this algebraic expression. Negative 8x. This is another term of this algebraic expression. What do these two terms have in common? You'd realize that they all have the variable x. Now, because they have the same variable, they are said to be alike. So 2x and negative 8x are like terms because they have the same variable. Let's also note that these two terms do not just have the same variables. The variables are also of the same exponent. So in 2x, that x has exponent of 1, and in negative 8x, that x has exponent of 1. So they have the same exponent. So that's also another reason why they are alike. Now let's look for another set of like terms or terms that are alike. So this is another set of terms that are alike, and for that matter can be described as like terms. They are like terms because they have the same variable y. The first term is positive 5y, and the second is positive 3y. They all have the variable y, so they are like or they are like terms. Again, the exponents of the two y's are also the same, 1, 1. So that's the second reason why they are alike, or they can be described as like terms. Let's look at another set of like terms. This set of terms are also alike. Let's note that they might not have the same variable, but then they are of the same kind. Plus 2 is of the same kind as negative 10. Remember, they are all numerical expressions, and for that matter, they are of the same kind, so they are also alike. So what this means that plus 2 or positive 2 is a like term to negative 10 or minus 10. So now let's revisit the definition of what like terms is. So two terms are alike or can be described as like terms if they have the same variable and if the variables are of the same exponent. And we can also even add that if the two terms are of the same kind. In the example we just saw, where plus 2 and minus 10, they are of the same kind, although they never had variables by them. So I believe this definition now makes sense. What this means is that when two terms do not have the same variable, or when two terms have the same variables of different exponents, or when two terms are not of the same kind, then they are not like terms. In other words, they can be described as unlike terms. Let's look at an example. So in this example, we have the term 2x or positive 2x, and we also have another term positive 5y. These terms are not like. In other words, they are unlike because they do not have the same variable. 2x variable is x and 5y variable is y. They are not having the same variable and they are not of the same kind, so they are unlike terms. And I believe if I ask you to look for all the pairs of unlike terms from this expression, you would be able to do so. I wouldn't do that, but at your own time, try and figure out what the pairs of unlike terms are from this expression. Now, I'll need us to note the following. Let's look at this algebraic expression. 2y squared plus 5y plus 2. Well, this type of algebraic expression, we call it the quadratic expression. We've not looked at quadratic expressions yet, but we'll be looking at that in the future. But of course, we are not really interested in the quadratic aspect of this algebraic expression. We are interested in the like terms and the unlike terms aspect of this expression. We would select two of the terms of this expression. The first term is positive 2y squared and the second term is positive 5y. So what can you say about these two terms? Are they alike or are they unlike? First, you would realize that both terms have the same variable y. So in the first term, you have the variable y in there, and also in the second term, you find the variable y. However, you'd realize that the y in the first term has exponent of 2, whilst the y in the second term has exponent of 1. So the two y's are not of the same kind. In fact, they are different. So what this means is that the first term and the second term are not of the same kind. So they are not alike. In other words, they are unlike terms. Let's look at another example. We have 3my squared plus 7m squared y minus 1. This is another algebraic expression, and it's also another example of a quadratic expression. But like I've said earlier on, we are yet to look at quadratic expressions. Let's select two terms of this expression. The first term of this expression is positive 3my squared. Let's note that the square only affects the y. It is only the y that is squared. The second term is positive 7m squared y. And here too, I'll need us to note that the square only affected the m. It is only the m that has been squared in this term. Again, what can you say about these two terms of the algebraic expression? Are they alike or are they unlike? First, let's note that the two terms have the same variables. The first term has the variables my and the second term also have the variables my. These variables are the same. However, my square is not the same as m square y. For my square, it is the y that has been squared, and for m square y, it is the m that has been squared. So although we have the same variables m and y in both terms, the two items are not the same. What this means is that the term 3my square and the term positive 7m square y are not alike. Let's look at another example. So we have 3y square plus 5y square plus 2. That is the algebraic expression given to us. Let's select two of the terms of this expression. The first term is 3y square, and the second term is positive 5y square. What do you think about these two terms? Are they alike or are they unlike? You'd realize that these two terms have the same variable y. So in the first term, you find the variable y, and in the second term, you'd also find the variable y. Also, in the first term, you realize that the y is squared, and in the second term, the y is also squared. So clearly, these are the same. So what this means is that the term 3y square is of the same kind as the term positive 5y squared. We can therefore say that the two terms are alike. Let's take another example. And in this example, we have positive 3my squared plus 7my squared minus 1. Let's select two terms of this algebraic expression. So the first term is positive 3my squared. And remember, in this term, it is the y that has been squared. The second term is positive 7my squared. Here too, it is the y that has been squared. Now, are these two terms alike or are they unlike? First, you would realize that they all have the same variables. The first term has the variables my. The second term also have the variables my. Again, in the first term, the m variable has exponent of 1 and the y has exponent of 2. In the second term, the m has exponent of 1 and the y has exponent of 2. So clearly, you realize that these two variables are not just the same, but they are also of the same kind. So what it means is that 3my square is of the same kind as positive 7my squared. Therefore, the two terms are alike. Well, friends, this is where we bring part 1 of algebraic expressions to an end. In our next meeting, we'll be looking at the part 2 of algebraic expressions. And under part 2, we would be looking at operations on algebraic expressions. Thanks very much for staying with us. And please, I'll need you to subscribe to this channel if you've not already done that. Remember, once you subscribe and new videos are being done, you'll be given an alert of those new videos. Stay safe. We'll meet again in our next class.